So I'm going to take a look at a couple of these problems here from projectile motion. Let's look at number 3. We're looking at the soccer ball being kicked from ground level, okay, at an angle of 40 degrees relative to the horizon with a speed of 15 meters per second. We want to know how far the ball will travel. That's this distance x. The equation that we can use to find that distance traveled in the x direction is v0 cosine of theta times t. However, okay, we don't know the time. So we have to get the time from the y equation, reasoning that, and here's our y equation, that when it hits the ground, the height above the ground, y, is 0. So we put everything into our y equation. Gravitational constant of 9.8, half of that, negative 4.9 t squared, plus the initial velocity times the sine of the angle, times t. The initial height is at ground 0, so that's 0. Here we can solve this easily enough, okay? And we can pull out the t as a common factor. At the one first time t will be t equals 0 when it is first kicked, and the remaining will be the solution to this, which gives us, if we can take a look, I think I pulled that up on the calculator. I put that in here somewhere, okay? Got a couple calculations, so we'll show you right here. There it goes. I solved, here it is. Okay, I solved this equation right here. Solve. Negative 4.9 t plus 15 sine of 40 equals 0. Solve that, give me a t value of 196. Then I can throw that value 196 for 1.96 seconds back in here and find the distance that is traveled. Okay. This number 6 is almost the exact same problem. How far did it move horizontally? So the approach is very much the same. I can't find how far it's moved horizontally until I first find out how long it's in the air. I can find out how long it's in the air by, again, taking my equation y, setting it equal to 0, solving for t. This is a much longer period of time. Okay, again, I can show you that on the calculator. It's right over here. Okay, it's the same, almost same. It is exactly the same setup. Okay, the time it's in the air is 46 seconds. So 46 seconds plugged into the equation for x here will tell me how far it's traveled downwind, okay, or down the range of it, okay? Let's see. Here's a interesting problem, okay? Football, number 11, football kicked at an angle of 50 degrees from ground level. It travels 20 meters. So we want to know how long is it in the air and what was its initial velocity. So here's our equations, okay? Our x equation, v0 cosine 50 times t is equal to x, which we know is 20 meters. The equation in y, the usual equation, leaving ground 0 and hitting back to ground 0 means y is equal to 0. Okay? It means the h sub 0 is equal to 0. And to find the total time is in the air is when it hits the ground again, so that's when y is equal to 0. Okay? Both of these equations have an unknown, the velocity and the time. So what we have to do is we have to do a systems of equations. This v0 cosine 50 times t equals 20 can be solved for v sub 0 simply by dividing 20 by t cosine of 50. I'm going to do a substitution. I'm going to come over to this equation. I'm going to swing the negative 49 t squared over here, making it positive. I'm going to plug in my V0 as 20 over t cosine 50. I got a nice cancellation with my t's. I've got the sine 50 over cosine 50, which is just the tangent of 50. And so here I have 4.9 t squared equals 20 tan of 50. I can obviously solve that for t right here, 20 tan of 50 over 49 over 4.9, the square root of all that. I have that available here. I keyed that in. Gives me 2.2 seconds. I can come back over here with this equation for v sub 0, plug in my 2.2 seconds, and as a result of that will come out the velocity. And let's see what my calculator showed me on that. The 2.2 seconds went in, and that gave me a velocity of 14.14 meters per second. Let's see, we'll go through another one here. Okay, down here, this is number 16. The stone is thrown from the edge of a 15.5 meters. That's my h sub 0, 15.5. Okay, it is thrown with an initial velocity. There's my v sub 0. Downward at an angle of 15 degrees. So my angle is actually negative 15 degrees, since it's being thrown downward. How far from the base of the cliff does it land? Well, again, I can't tell you how far it's going to from the base of the cliff. That's this equation here, x equals v sub 0 cosine negative 15 times time. I don't have the time. So I have to go back to my y equation, find the time. Okay, here's my y equation, negative 49 t squared plus 45.4 sine of negative 15 times time plus 15.5. I've got to solve that for t. I've got that on my calculator. I'll show you how I solve that on my calculator. Here it is on my calculator. Solve negative 49 t squared plus 45.4 cosine negative 15t plus 15.5 equals 0. Solve for t. Gives me two values of t. I obviously did something wrong there. I can tell you what I did. I put the cosine in instead of the sine. So that's I know I did that wrong. So I'm going to come back here. I'm going to show you where I corrected that. That's right here. Okay, that's in with the sine of negative 15. That gives me two times, one being negative, which I'm going to throw away. The other time is just under a second, 0.945. So I'm just going to put that time in to this equation in x, and that'll tell me how far it's gone. So there you have it. There's some of the problems solved out for you. Hopefully give you a fairly good understanding on how to resolve the rest of them. Okay.